Welcome to all Vedic Maths teachers and Vedic Maths fans to this online worldwide conference, and welcome to my presentation. I am Anna Gerardina Foglino. I have Master Degree in Maths. I am Vedic Maths Certified Advanced Teacher. I am naturopath and expert in bioresonance. I am goal mapping practitioner and training online coach, the MIT consultant, and education for life. Today, we will speak about some Vedic math tools to solve logarithmic equations. Here the summary of this presentation. We will start to understand what logarithms are, definition as the reverse of power, then the properties and the rules to understand how to operate with addition, subtraction, multiplication. After, we will see 5 examples of logarithmic equations. In the first example, we work 4 terms. In the second, we will use Samochaya to solve the equation. In the third example, we have odd terms. In the fourth example, we have 6 terms. And in the last example, we use exponential function. We start with a brief understanding and review of logarithms. What are logarithms? We define y equal log base a of x. This means that a y power equal x. The logarithm is the reverse of exponential, and we can see here the sutra transpose and apply. This means that y is the exponent to elevate a to obtain x. Properties, we have 6 properties. 1. X greater than 0. As x is the result of an exponential function, it has to be positive. A negative logarithm doesn't exist. 2. Due to exponential properties, if x equals 1, the only possibility to have for the exponent is 0. If y is the logarithm in base a of 1, this means that exponent of a to have 1 as a result is 0. Y equals 0. Other properties. If x is equal a, that means the base of logarithm a is equal of the argument. The only possibility we have for the exponent is 1. So, if y is the logarithm base a of a, it is 1. We study the sign of the log base a of x when a is greater than 1. We have 2 results, 2 possibilities. If we take numbers greater than 1, the function is positive. If x is greater than 0 and less than 1, the function is negative. If we study the sign of log base a of x, when a is greater than 0 and less than 1, the situation is opposite. We have 2 possibilities. If we take numbers greater than 1, the function is negative. If x is greater than 0 and less than 1, the function is positive. Here are the graph for better understanding. The green slope is for a base greater than 1. I chose a equal 3 up to. So we have y equal log base 3 up to of x. The blue slope is a base greater than 0 and less than 1. So a is equal 2 up 3 and y equal log base 2 up 3 of x. Now we look at some rules that will be useful for our exercise. The product rule comes from the product of powers rule. In a multiplication problem involving exponents, if the bases are the same, the multiplication problem can be simplified by adding the exponents. So, in the product rule, the logarithm of the product of two numbers is the sum of the logarithm of these numbers. The quotient rule comes from the quotient of powers rule, where the exponents are subtracting. In the quotient rule, the logarithm of the quotient of two numbers is equal to the logarithm of the numerator minus the logarithm of the denominator. The power rule of logarithm of a power number is the product of the exponent of the number with the logarithm of the number. We are happy to solve some logarithmic equations. We assume that the base a is 10 and we don't write it. First problem, we want to find the solution of this equation. Log of x plus 1 minus log of x minus 1 minus log of x minus 2 equal log of 8. We have to find the solution with first the domain. Each argument of logarithm has to be positive. So we find a system of inequalities. X plus 1 greater than O, x minus 1 greater than O, x minus 2 greater than O, and 8 greater than O. The last is always true. By the mere observation, the solution is the maximum of values. So the solution is x greater than 2. In step 2, we rearrange the equation in order to have all positive on the left and all positive on the right. So we have this equation, log x plus 1 plus log x minus 1 equal log 8 plus log x minus 2. In the step 3, we use vertically and crosswise on the argument of the left side and on the argument of the right side. We write the arguments of the first part one behind the other, and we do the same on the right side. We multiply vertically each side using the sutra vertically and crosswise of the general multiplication. So we obtain on the left side e squared minus 1 and on the right side 8x minus 16. The quadratic equation we had is a squared minus 8x plus 15 equal 0. To find the solution, we have to find two numbers that add up minus 8 and their product is 15. These two numbers are minus 3 and minus 5. So the solution are x1 equal 3 and x2 equal 5. To find the solution of this logarithmic equation, we only need to compare the results of the equation we found before with the domain. As both are greater than 2, both are the solutions. Here another example. We have to find the solution of this equation. Log 3x plus 2 minus log x plus 4 equal log 2x plus 3 minus log x plus 6. First step, each argument of logarithm has to be positive in order to find the domain. This means a system of inequalities. 3x plus 2 greater than 0, x plus 4 greater than 0, 2x plus 3 greater than 0 and x plus 6 greater than 0. By the mere observation, we know that the solution is the maximum of values. This means x greater than minus 3 up 2. In step 2, we rearrange the equation in order to have all positive on the left side and all positive on the right side. So we have the equation in this form. In the step 3, we use vertically and crosswise on the argument of the left side and the argument of the right side. We write the argument of the first part one behind the other, and we do the same on the left side. Now, before multiply each side using vertical and crosswise, we observe the independent terms. We know that when the samuchaya is the same, is 0. Here, the samuchaya is the product of independent terms. The samuchaya is 2 multiply 6, 12 on the left side, and 4 multiply 3, 12 on the right side. The samuchaya is the same, so one solution is 0. To find the other solution, we multiply vertically each side using the sutra vertically and crosswise general multiplication. We find on the left side 3 is squared plus 20x plus 12 equal 2 is squared plus 11x plus 12. The final equation is x squared plus 9x equal 0. One solution we know is 0, the other solution is x equal minus 9. To find the solution of the logarithmic equation, we compare the solution x1, x2 with the domain, and we find that x equal 0 is the only solution. Here another exercise. We want to find the solution of log x plus 1 plus log x equal log 2. We have odd terms. First of all, we find the domain. Each argument has to be positive. That means a system of inequality, x plus 1 greater than 0, x greater than 0, and 2 greater than 0. This is always true. By the mere observation, we know that solution is the maximum of value. This means x greater than 0. In step 2, we already have all positive. We need only to put on plus 0 to have the same element of both sides. This means to add log plus 10 1. And so we have the same element. We use vertical and crosswise on the argument of the left side and on the argument of the right side. We write the argument of the first part one behind the other, and we do the same on the right side. As we see, the right side is very easy in this case. And we multiply each side using the sutra vertically and crosswise of the general multiplication. The right side is only vertical multiplication. We find x squared plus x equal 2. This means x squared plus x minus 2 equal 0. This means to find two numbers that add up 1 and the product is minus 2. These two numbers are 2 and minus 1. So the solution are x1 equal minus 2 and x2 equal 1. To find the solution of this logarithmic equation, we only need now to compare the results of x1 and x2 with the domain. The domain is only numbers positive, so we choose only x equal 1. One more note about this equation. We can find the solution also by the mere observation. In fact, x equal 1, it's easy to understand that is the solution. If we put x equal 1, here we have log 2 equal log 2, very easy. One more example, we want to find the solution of this equation. Logarithm 2x minus 1 plus log 3x minus 8 minus log x minus log x minus 2 equal log 5 minus log 3. The first step is to find the domain. The domain is the system of inequality of the arguments. As we saw before, by the mere observation, the solution is the maximum of the value. So we accept all the solutions that are greater than 8/3. In the step 2, we rearrange the equation in order to have all positive on the left side and on the right side. We use vertically and crosswise on the arguments of the left side and on the arguments of the right side, and we find this result, and we have this equation: 13x squared minus 47x plus 24 equals 0. To find the solution of the equation we have found, we use the Vedic method for a quadratic equation. The solution is the differential is equal the square root of the discriminant. We do the differential of the equation. We have 26x minus 47 equal plus minus the square root of the discriminant. So we have the solution that are 3 and 8/13. Now we compare this solution with the domain, and we accept only x equal 3 because it is bigger than 8/3. Here the last example of logarithmic equation. We have 3 log x minus 2 equal log x plus log x squared minus 14. And we have to find the domain. The domain is the system of inequalities of the argument. And by the mere observation, we find the solution is the maximum of the values. That means x greater than square root of 14. In the step 2, we use the power rule. So the 3 that multiply log x minus 2 become log x minus 2 power 3. So we have this change. In the step 3, it doesn't need to rearrange in order to have all positive. Only we need to put a 0 to have the same elements, quantity of elements on both sides. So we put a log 1, that means 0, on the left side. In this case, we need only to multiply vertically on the left side, on the right side the arguments, because we have 1 on the left and x on the right. And we do the cube and we do the multiplication, and we find this quadratic equation: 6x squared minus 26x plus 8 equals 0. To find the solution of this quadratic equation, we observe that the middle terms, minus 26, is an even number. So we can create a Vedic method reduced formula for a quadratic equation, in which we divide by 2 the differential and we divide by 4 the discriminant. The discriminant so become the middle term divided by 2 squared minus the first term for the last term. We apply this to our equation, so we have 12x that becomes 6x minus 26 that becomes 13 equal plus minus the square root of 30 squared minus 6 by 8, 48. So we can find the solution with some other work and find that x1 is equal 1 over 3 and x2 is equal 4. To understand what is the solution, we need only the last step in which we compare the solution of the quadratic equation with the domain. And we upset x equal 4, that is greater than 8 over 3. In conclusion, logarithmic equations are more light with very maths, and for me and my son, it was a very funny play to discover them. Thank you.